Hello dear student, welcome back to the series of database management system. Now we are going to see constraints in DBMS. Constraints are rules that enforce certain restriction on data in a database. They help maintain the accuracy and integrity of the data by ensuring that only valid data is stored within the database. Here are the main types of constraint used in database. So constraints are nothing but we are imposing certain rules for entering the data into the database. We are imposing some restrictions on that. Okay, so that means it will maintain the accuracy and consistency and integrity of the data. Our first constraint is primary key constraint. A primary key is a constraint in a table which uniquely identifies each row record in a database table by enabling one or more the column in the table as primary key. Primary key cannot be null and primary key cannot be duplicated. So primary key is one which uniquely identify your table and it cannot be null and duplicated. For example, see, we have a student table. Here we have records roll number, name, age and CGPA. So which is the record which uniquely identifies, which is the column or field which will uniquely identify each records of the table? So roll number is my primary key which will uniquely identify all the records of the table. So while creating table we have to write create table, name of the table, that means student, roll number, int, that means the data type, and we have to write that this is my primary key. Okay, by writing this we are going to tell your compiler that this is my primary key. It should always accept the unique value and it should not accept null value. Okay, next is foreign key constraint. The foreign key constraint is a column or list of column which points to the primary key column of another table. The main purpose of foreign key is only those values are allowed in the present table that will match to the primary key column of another table. So what is foreign key? Primary key of one table will act as foreign key in some another table. While entering the data, we should always, or it should always allow only the values which are present in the other table's primary key. Okay, for example, see, we have student table. Okay, in that we have roll number, name and course ID. Next we have student marks. In that I'm taking course ID and marks. Okay, now here my course ID is suppose my primary key. Okay, and here in another table the course ID will act as a foreign key. Okay, so that means we can refer to the primary table's course ID, and here suppose see IT101 whose course is IT101 Arya. Arya got 100 marks. Next is IT102 Bran. Bran got 99 marks. Okay, and next is IT103 John. John got 93 marks. Next is unique constraint. Sometimes we need to maintain only unique data in the column of database table. This is possible by using unique constraints. Unique constraints ensure that all values in a column are unique. So if we make any column as unique, if we declare any column as unique, it will just accept the unique data. Okay, no repetitions allowed. For example, see, I have declared my roll number as unique. So while writing or while creating table, I will create table person roll number int unique. Okay, so that means I have declared this column as unique, so it will not accept any duplicate value. All values are different. Next constraint is check constraint. Suppose in real time if you want to give access to an application Only if the age entered by the user is greater than 18, this is done at the back end by using a check constraint. For example, like in Facebook, Instagram, while entering your details or while opening your account, it will ask you that are you greater than 18? If yes, then only the data will get inserted. That is the check constraint. Okay, where in at the background it is going to check that if age is greater than 18, then only login is allowed. Check constraint ensures that the data entered by user for that column is within the range of values or possible value specified. For example, see, allow data only if age is greater than equals to 18. So we have to apply the constraint on age attribute. So I am creating a table student where roll number int, name is my varchar and age is int. Then I am imposing constraint as check. Age should be greater than equals to 18. If my age is less than equals to 18, it is going to give me error. Next is default constraint. Default clause in SQL is used to add default data to the column. When a column is specified as default with some values, then all the rows will use the same value. That is, each and every time while entering the data, we need not enter that value. But default columns value can be customized. That is, it can be overridden when inserting a data for that row based on the requirement. So what is default constraint? We are passing the value while creating the table only. Okay. So by default it will consider that value only if you do not enter the data. But while inserting data, if you enter the value, it is going to override the value of that column. For example, see, I am writing a query, create table employee, ID number int not null, name varchar not null, and company varchar default, prep insta. So that means what? By default, my company name is prep insta. If I do not insert any another data of my company name, by default it will insert prep insta to all the values. Next constraint is not null constraint. Null represents a record where data may missing data or data for that record may be optional. Once not null is applied to a particular column, you cannot enter null values to that column and restricted to maintain only some proper value other than null. A not null constraint cannot be applied at table level. For example, if I want that if the certain column or certain row should not accept the null data, I will impose my uh, attribute or my data with not null constraint. So for example, see, create table student roll number int not null. That means I cannot insert null values into the roll number column. Next is mapping constraint. Mapping constraint defines how many entities can be related to another entity to a relationship. It is very much useful for identifying relationships that are involved with more than one relationship. Simple binary relationship with two entities set, then four possible mapping cardinalities to exist as follows: one to one to many to one, and many to many. One to one, when a single instance of entity is associated with single instance of another entity, then it is called as one to one. For example, see, one male married to one female only. One to many, when is a single instance of an entity is associated with more than one instance of another entity, then this type of relationship is called as one to many relationship. For example, one customer can place many order. Next is many to one, when entities in one entity set can participate only once in a relationship set, and entities in another entity can participate more than once in the relationship set. Then such entity is called as many to one. For example, many students joins one college. Next is many-to-many cardinality. Here, more than one instance of an activity is associated with more than one instance of another entity